Hi everybody, in lecture 9, you're going to see how to perform hypothesis testing using t-distribution. So by the end of this week, you should be able to define hypothesis testing. You should be able to formulate the null hypothesis and the alternative hypothesis. You should be able to perform hypothesis testing using t-distribution. And finally, you should be able to identify the risk that follows if we wrongly reject the null hypothesis. So in this part 1, you're going to cover most of these 3 sections. Part of this section will be covered in part 2 of the lecture, and this will be covered in part 3 of the lecture. Okay, so before we start this lecture, let me ask you a question. What is hypothesis? Good. Hypothesis is a statement or an idea or an assumption that can be tested using an observation or experiment. For example, if a scientist decides to answer questions like, does a fertilizer increase the yield of a particular type of crop? Does a certain supplement diet improve weight gain in babies? Does a new medicine improve a certain medical condition? Or given the situation, does the new vaccine prevent people from getting COVID-19? So all these can be answered if the scientist can give us a statistical evidence. That is, what does the scientist do? The scientist will choose a random sample from the population and test it. That is, a sample is chosen from the population and the treatment is applied on the sample. A treatment is applied on the sample. And then the hypothesis is tested. Has the treatment had the desired effect? In real life, the experiment is repeated, and if the experiment is reproducible, the treatment is applied to the whole population. So, what is hypothesis testing? It is a formal process that provides a framework to help us make a decision whether the treatment has had the desired effect. Okay, now let's go back to the last week where we did the sampling distribution. We know how to state a distribution. Okay, so now in a sampling distribution, all samples are possible, and most of the samples will have a mean in this green region, in this part of the distribution, which is most likely to happen. Yeah, that is, if I conduct an exam for you guys, most of you will score in the likely region. Very few or none of you will fail. That is unlikely to happen. Some of you will get full mark, 100 out of 100. So some samples will have a mean in the tails of the distribution with low probability. Happening of this in this region, in the red region, is very unlikely, or the possibility is that it could happen with a low probability. Okay, so we can say that samples in the upper and the lower tail of the distribution will have low probability of occurring. It is highly unlikely that the sample mean will occur in this region, in this red region. For example, what is the probability of getting 9 head and 1 tail with 10 tosses of a fair coin? Good. It is highly unlikely, isn't it? So such samples can be considered as unlikely to occur, or they occur by chance. Therefore, we can say that or state what is hypothesis testing. Sorry. Hypothesis testing is about making a decision about some statement or belief based on what we observe and using statistical evidence. You know how to give a statistical evidence by determining the probability. So by using probability to determine whether an observation falls in the defined unlikely region. So you can calculate the probability to show the statistical evidence to see whether you will accept a hypothesis or you will reject the hypothesis. So if it lies in this unlikely region, the red region, based on that, we're going to decide whether you're going to accept the hypothesis or reject a hypothesis. Now, to understand the different steps to perform hypothesis testing, let's take an example because it's easy to understand the whole process by taking an example, okay? So let's say that a group of scientists have developed a new plant feed and they are testing it on a sample of 16 plants. That means the sample has got 16 plants, or the sample size is 16, n is equal to 16. If the plant is grown without the feed, before the feed was applied, before the feed was developed or invented or discovered, whatever it is, before the feed was applied, the plants used to grow to a height of 50 centimeter. So that was the population mean. Yeah, before the plant feed was applied. Now, when the plant feed is applied, they noticed that for this sample, the mean height was 52.7. So this is your sample mean, yeah, which is represented in h bar as h bar. It's the same as x bar. It is just because now x is being replaced by h because it's the sample mean height, okay? So h bar is equal to 52.7. That is for this particular sample. For this particular sample of size 16 or with 16 plants in this sample, the sample mean height was 52.7 with a standard deviation for the sample as 5.1 centimeter. Okay, so just using this one sample, can you say that whether the feed has worked? Can you say that the feed has improved the height of the plants just by one sample? Yes, you can see that the sample height of the mean sample height has increased from 50 to 52.7. It has increased. It has increased from 50 to 52.7. 52.7 is greater than 50. It appears that the feed has worked, but it is based on one sample. So it could be just a reasonably likely sample from a distribution where the mean is 50. That is a chance event where the mean is actually unchanged. It could be that also, yeah? So how are we going to test this? And we're going to follow 1, 2, 3, 4, 5, 6 steps to carry out the test to see whether our feed has worked or not. Okay, so first let's see what is the step 1 and step 2. That is how to set the null hypothesis and the alternative hypothesis. We're going to do step by step. So before we set the null hypothesis, what is a null hypothesis? What is it? Null hypothesis is generally an accepted fact, generally accepted as being true. Let's take a simple example. Earth is not flat. You all accept it? Yes? It is a generally accepted fact. Earth is not flat. Or there are 8 planets in the solar system. Again, it's a generally accepted fact. Smoking can be injurious to health. Again, it's an accepted fact. So all these are called null hypothesis. A generally accepted fact or generally accepted as being true are null hypothesis. Can you think of any good examples of a null hypothesis? Good. A null hypothesis is accepted to be true until a statistical evidence, that is by calculating the probability, you can nullify it for an alternative hypothesis. Okay, To understand this statement, you need to know what is alternative hypothesis. Because a null hypothesis is accepted to be true. This is accepted. The earth is not flat, is accepted to be true until you can prove by some experiment or by using statistical evidence. And you can nullify it for an alternative hypothesis. Okay. So what is an alternative hypothesis? It is an hypothesis that is opposite to null hypothesis. It states what happens if an experiment makes a change on the sample, proposing something might happen, proved with statistical evidence. Okay, let's take a simple example to understand that. Years ago, the accepted fact about the earth was that it was flat. Yeah, we used to believe, that the earth was flat. So let's consider that as null hypothesis. So now we're considering that the null hypothesis. Let's go back to that era when we believed that earth was flat. So at that time, we would say that, okay, that's an accepted fact. Earth is flat. Null hypothesis was the earth was flat during that time. Then we had many scientists who came along and disproved this fact. And we had an alternative hypothesis that the earth is almost round. So that is the alternative hypothesis. And now we have proved it by experiments and calculations that earth is almost round. So we accept the alternate hypothesis and we reject the null hypothesis. We reject the fact that earth was flat. We reject null hypothesis and we accept alternative hypothesis. That is, the null hypothesis was nullified in this case or rejected, and the alternative hypothesis, that is, earth is round, is almost round, is accepted. Got it? So alternative hypothesis, what is that? It is just the opposite of null hypothesis. That is, it tells you that there is a change. It has made a change. There is a change, okay? And null hypothesis, no change. Okay. Now, state the null hypothesis for the example you have stated for the, state the alternative hypothesis for the example you have just stated for the null hypothesis. Good. So we have seen what is null hypothesis and what is alternative hypothesis. And let's see how to apply it to a test, okay? We'll see that soon, yeah? So null hypothesis, we assume there is no change, okay? So let's go back to the same example, plant feed example. If the plant feed problem, in the plant feed problem, let's assume that the mean of the population after the plant feed was applied still remains 50. There is no change. The treatment has not worked. Let's assume that. That is our null hypothesis. Okay, let's assume that. Even though the treated sample gives a mean of 52.7, let's assume that the treatment has not worked. That is, let's assume there is no change. Then that is how we state our distribution, sampling distribution. We denote the null hypothesis mathematically using this notation. That is, for the null hypothesis, the population mean is 50. That is, we are assuming that there is no change, the treatment has not worked, and the population mean is 50. Okay, so no change, the feed doesn't work, the mean is unchanged, remains 50. That is our null hypothesis. So first step is set the null hypothesis. Now let's go to the second step. Set the alternative hypothesis. There is a change. Here we want to see whether the feed has improved the height. Is there an increase in the height? That's our alternative hypothesis. We need an alternative hypothesis denoted by H1. This is how we denote H1. which we will accept when we reject the null hypothesis. So how do you state it? For the plant feed problem, we are looking for a test for an increase in height. So the alternative hypothesis is given as the population mean has increased, is greater than 50. So we may have examples, okay, not for this example, some other examples where the height would have been decreased. So in such cases, we use less than 50 if the test is for a decrease in the mean, or sometimes we are in a situation where we don't know the type of change. We don't know whether there is an increase or decrease in the height. We are not sure about it. We don't know. We have no idea whether the mean increases or decreases. But we know that this is a test of change. So we use the symbol not equal to, because we are not sure. We have no idea whether the mean has increased or decreased. And we use not equal to. Okay, if it is decrease in the mean, we use less than. If we have no idea about the change in the mean, then we use not equal to. And like in this example, plant feed problem, we know that from the sample, there can be an increase in the height due to the plant feed, and we can state the hypothesis, alternative hypothesis, as population mean is greater than 50. Okay, now we know what is alternative hypothesis. We have set the alternative hypothesis for a plant feed problem, for the problem which we were talking about. So we have to state this clearly when we are solving any hypothesis testing problem, okay? Or when we are performing a hypothesis testing. That is, set the null hypothesis to state no change in the mean. This is what is to be tested. Then set the alternative hypothesis depending on the test. This is what is accepted if we reject the null hypothesis. Now for the following example, set the null hypothesis and alternative hypothesis. Good, very good. Now the third step is to set the level of test. Okay, what am I talking here? Yeah, let's see that. What is setting the level of test? It is setting a low probability for the tail of the distribution. Here, 5% has been chosen as the level of test. Usually we choose 5% or 1% for a hypothesis testing. Yeah. If the observed sample mean occurs in this region, in this red region, in the rejection region, you reject the null hypothesis. That is, we reject the assumption that the treatment hasn't worked, because the probability associated with the sample mean is too low. Yeah. So we reject the null hypothesis. And we accept the alternative hypothesis. That is, the plant feed has worked. Okay. So in the real world, this level of test is chosen by the person who is performing the experiment. Yeah. But for you during this course or in the exam, the level of test will be set for you. Okay. Okay. So we know what is step 3. Step 1, null hypothesis, set the null hypothesis. Step 2, set the alternative hypothesis. Step 3, set the level of test. And this level of test should be a low probability, as low as possible. Yeah. Okay, step 4. We have to determine the sample mean and the standard deviation for the sample. And you know how to do that. We did that in week 1. Yeah. So you can calculate the sample mean and standard deviation using the formula from the sample. Okay. Step 5. Now is the real problem coming, yeah? To determine if the sample mean falls in this critical region, because we need to see whether our sample mean lies in this region. If it lies in this region, reject the null hypothesis. If it lies in this region, accept the null hypothesis, yeah? So that is your rejection region. And to see that, you need to find the probability. And to find the probability, we have to transform this into a standardized normal distribution using this transformation formula. Okay, now for the plant feed problem, we can transform this distribution into a standardized normal distribution. We know the sample mean, the observed mean for this treated sample. We know the null hypothesis, which is 50. I mean, because that's a null hypothesis, because null hypothesis is no change. So population mean remains 50. And we know the sample size. So we know this, we know this, we know this. Ooh, we don't know the standard deviation of the population. In the real world, standard deviation is rarely known. So what do we do if we don't know the population standard deviation? What do we do? So we will see that in part 2. Okay, thank you guys.